Welcome friends. Through this video, I am going to discuss some problems of differential equation involving order, degree, formation of differential equation. How to find order, how to find degree, how to form differential equation. These are problem of competitive examination. So, very simple problem. It will take very few time to solve this type of problem of JEE Main and West Bengal JEE. So, I have already discussed the theory of these topics. Now, I will solve some problems. So, from description box, so problem number 1 to 7, 10, 12, they are of same type. So, how to find order and degree? So, suppose problem number 5. So, x equals to 1 plus dy by dx, 1 by factorial 2 dy dx whole square, 1 by factorial 3 dy dx whole cube. So, you have to find degree of the differential equation if it exists. Now, look. It is right hand side is formula of e to the power x, 1 plus x by factorial 1, x square by factorial 2, x cube by factorial 3, dot infinity. This is formula of e to the power x. So, if we simplify, so look, the problem number 5, right hand side reduces to x is replaced by dy by dx. So, e to the power dy by dx. So, if we take log x base e equals to dy by dx. So, what is the degree? So, dy dx. So, order is 1 and degree equals to. So, what is the degree of the differential equation? So, degree is 1. So, you need only formula of exponential function. Now, so problem number 3. So, m is the order and n is the degree. Find order and degree of the differential equation. This is also simplest problem. So, this dash represents derivative. So, simplify it. So, y triple dash into y double dash whole to the power 5. So, 4 y double dash whole to the power 5 plus y triple dash whole square. So, sin x into y triple dash x. So, maximum number of derivative. What is maximum number of derivative? Here it is triple dash x. Here it is triple dash x. So, maximum number of derivative is 3. So, order is 3. Now, power of maximum derivative. Here it is triple dash. Here it is also triple dash is 1. So, here power is 2. Here power is 1. Here also 1. So, maximum power of highest order derivative. So, this one. So, degree equals to 2. So, order is very simple, maximum number of derivative and power of maximum number of derivative. So, this is degree is 2. So, these two are very simple problem. Next, problem number 11. The order and degree of the differential equation representing this. So, order and degree. So, relation is given. So, how many arbitrary constant? Only one, that is C. So, it is obvious that order is 1 because only one constant. Now, you have to find degree. You have to find differential equation obtained from the relation. So, let us try to find the differential equation. So, if we differentiate 2y dy dx equals to 2c. C to the power 3 by 2, this is 0. So what is c? Y into dy dx. So eliminate c from relation 1. So if we put value of c, so y square equals to 2cx plus 2c to the power 3 by 2. So 2x unchanged. C is y dy dx plus 2y dy dx whole to the power 3 by 2. So y square minus 2xy dy dx equals to 2y dy dx whole to the power 3 by 2. So this is not integer, so radical sign you have to eliminate. So taking square on both sides, y square minus 2xy dy by dx whole square equals to 4 into y dy dx whole to the power 3. So what is order? Order is 1 dy dx, and look, if we take square of the left hand side, so maximum power of dy dx is 2, but in right hand side maximum power is 2. So what is the degree is 3. So the order and degree of the differential equation. So order is 1, degree is 3. So these are very simple but important problem also. Now there are some same type of problem. General solution is given. You have to find order of the differential equation. So problem number 16. So this one is relation. So C1, C2, C3, C4. They are C4 and C5. They are arbitrary constant. So apparently there are 5 constants. So if there are 5 constants, then order is 5. But you look here, some constants are dependent to other. So we can reduce number of constants. So look, C1 plus C2, this is sum of constant. It is a single constant. So suppose this is A. Cos C3 plus x unchanged. Now this is C4 e to the power x into e to the power c to the power 5. So A cos C3 plus x minus C4 into this is B e to the power x. So what is A? C1 plus C2. And what is B? C4 into the power C5. So look, number of independent arbitrary constant here. So this is A is 1, this is 1, this is C3, this is 2, and this is B. So although the given general solution has 5 constants, but they can be reduced to 3 because they are dependent. So by considering C1 plus C2 as A and this as B. So how many constants? A, C3 and B. So order equals to 3. Order equals to 3. So independent constant is 3. So order is 3. So this is problem of JEE Main. So look, very simple problem. Now exactly same problem. Problem number 15. So C1, C2, C3, C4, C5, C6 are arbitrary constant. Then order of the differential equation we have to find. So y equals to this. So formula of cos A plus B. Cos x sin C2 minus sin x cos C2. C3 sin x cos C4 plus sin C4 cos x. Cos x plus C3 into e to the power minus x plus C6. So if we take cos x common, y equals to this. So cos x common. So what we are getting? C1 sin C2, and this is C3 sin C4 plus sin x common, sin x common, so C3 cos C4 minus C1 cos C2 plus C3 e to the power minus x plus C6. So now look, this is sum of constant, so it is a single constant, capital A. This one is capital B sin x. This one we consider as, this is A, this is, then C3 e to the power minus x plus C6. So how many arbitrary constant? Independent arbitrary constant are A, B, C3 and C6. So given solution contains 6 constants, but it can be reduced into 4. So A, B, C3 and C6. So what is order? Order equals to 4. Order is 4. Next, problem number 13. Exactly same problem. Problem number 13. So order of the differential equation whose general solution is this. So 1, 2, 3, 4, 5. 5 constant. So you have to find number of independent arbitrary constant. So look, if we take e to the power x common, this is C1 plus C2. C3 plus C4, this is a single constant. So C5 into e to the power x. So this one is B. So B into e to the power x, A into e to the power 3x plus 5 plus C5 e to the power x. So number of independent constant. So how many? 3. 3 constants. So what is order? Order is 3. Order is 3. So you have to find number of independent arbitrary constant. So these are of another type. Now we consider some typical problems. So formation of differential equation. So 17, 21, 22. So consider problem number 22. X square y square plus lambda, y square by b square plus lambda equals to 1. So how many constants? A, b and lambda. But look, find differential equation by eliminating lambda only. That is, lambda is variable constant. A and b are fixed. So final solution contains A and B. So this is also problem of derivative. So call it 1. So if we take differentiation, so 2xy a square plus lambda, 2y y1 by b square plus lambda equals to 0. So what we are getting? X by a square plus lambda plus y y1 by b square plus lambda equals to 0. So our meaning is to eliminate lambda. So minus y y1 by b square plus lambda. So call it, they are same, so we take them as 1 by k. We can take it k also, they are same, but we are taking 1 by k. Why? You look. In this case, we get a square plus lambda equals to ax and b square plus lambda equals to minus ay y1. So if we subtract, you look, lambda is cancelled out. So a square minus b square equals to kx, k common, x plus y y1. So call it a square minus b square kx, so this is plus. So from 1, so our main aim is to find lambda. So lambda you have to eliminate. So from 1, so if we put value x square by, what is a square plus lambda? You look, this is kx. Y square by, what is b square plus lambda? B square plus lambda minus ay y1 equals to 1. So one x is cancelled, one y is cancelled out. So xy1 minus xy1 minus y, xy1 minus y equals to k, equals to k. So x by 1x cancel, xy1 minus this minus y, y. So k is to the right hand side. So put value of k from here. So we are getting, so put value of k. So what is k? K is from 2. So from 2. So if we put value of k, so a square minus b square. So this one is a square minus b. So a square minus b square equals to, what is k? What is k? K is xy1 minus y. This is value of k, and this is x plus y, y1. So we are getting a relation which is free from lambda. Our main aim is to remove lambda, not a and b. So only you have to differentiate one times. That is why y1 represents dy dx. We are getting first order differential equation. So this is a typical type problem. You have to remember this step. So differentiating this a square minus b square. So you are getting value of k. So put these values in 1. You are getting k. Make 2k equal, and you get required differential equation. Next, problem number 21. So the differential equation of all straight lines which are at a constant distance from origin. So we need idea of coordinate geometry. So what is equation of straight line? So you know it is of normal form. So distance of p, and if this angle is alpha. So what is equation of line in normal form? X cos alpha, y sin alpha equals to p. Constant distance p. This p is fixed. This p is fixed. This is not variable constant, but alpha is variable. You may get different alpha in second quadrant, but this length p is same. So here you have to eliminate alpha. Alpha is variable parameter, a variable constant. So we eliminate alpha, not p. So same procedure. So differentiating with respect to x. So cos alpha plus sin alpha into dy dx. So with respect to x, cos alpha, sin alpha into dy dx. So cos alpha, so sin alpha dy dx equals to minus cos alpha. So dy dx equals to minus cot alpha. So minus cot alpha. That is, we are getting cot alpha equals to minus dy by dx. Now we need value of cos alpha and sin alpha. So from trigonometry, if we know cot alpha, so you get cos alpha as base, and this is perpendicular is 1. So minus dy dx by root over 1 plus dy dx whole square, base by hypotenuse. And what is sin alpha? Sin alpha equals to 1 by, base is this, so 1 by root over 1 plus dy dx whole square. Now remember, here cot alpha is positive. So if we take cos alpha as positive, then sin alpha is negative. So cos is negative, sin is positive. So it will be, if it is minus, then it is plus. So plus, minus. So we are getting cos alpha and sin alpha. So put these values of cos alpha and sin alpha to given relation 1. So what is our relation? So look, x into cos alpha. What is cos alpha? cos alpha. So minus plus dy dx by root over 1 plus dy dx whole square. This one y sin alpha plus minus 1 by root over 1 plus dy dx whole square equals to b. So finally what we are getting, you look, if we take this as positive, so y, then this must be negative, x dy dx. It is positive, so x dy dx equals to p into root over 1 plus dy dx whole square. So this one, or you can take this is minus y plus x dy dx equals to p into root over 1 plus dy dx whole square. These are the possible cases. So if we take square on both sides, so square, so we get y minus x dy dx whole square equals to p square into 1 plus dy dx whole square. So this is differential equation. So this is of order 1 and degree 2. So if we take square, so these two, so this is a minus b whole square, so b minus a whole square, they are same. So you remember, it is a constant length, so p is fixed constant. You have to eliminate the variable constant. Next. So problem number 17. So this is problem of derivative also. We have solved this type of problem. So if it is problem like that, find dy dx. So we have to use trigonometric transformation. You know, it is 1 plus x square. So what is trigonometric transformation? X equals to tan theta, y equals to tan of phi. So 1 plus tan square theta, 1 plus tan square phi, k into tan theta, 1 plus tan square phi minus tan phi root over 1 plus tan square. So finally we are getting sec theta plus sec phi, k into tan theta sec phi minus tan phi sec. So it reduces to problem of trigonometry, 1 by cos, 1 by cos phi. So we have some similar like problem in part 1 of derivative. So 1 by cos phi, this is sin phi by cos phi, 1 by cos theta. So look, LCM is cancelled out, cos theta plus cos phi, k into sin theta minus sin phi. So it is free from root over. Now use trigonometry. So this is 2 cos theta plus pi by 2, cos of theta minus pi by 2, k into 2 sin theta minus pi by 2 into cos of theta plus pi by 2. So 2, this is cancelled. So cos by sin, this is tan theta minus pi by 2 equals to k. So theta minus pi equals to 2 tan inverse k. So you put value of theta and pi. Actually, it is problem of derivative also. So this is theta tan inverse x minus tan inverse y. 2. This is not tan, this is I think cot. So this is cot, sorry. So 2 cot inverse k. 2 cot inverse k. So this is relation free from root over. Now take derivative, differentiating with respect to x. So 1 by 1 plus x square, 1 by 1 plus y square, dy dx equals to square. So what is dy dx? Dy dx 1 plus y square, 1 plus x square. So this is differential equation. What is degree? Degree is 1. Order is also 1. So you can write the order without finding differential equation. So to find degree, you need the differential equations. So this is differential equation. So these are the three important problems. Now we consider three problems. These are very simple problems because relation is given. We have to find differential equations. So problem number 24. So look, A and B are arbitrary constant. A and B are arbitrary constant. We have to form differential equations. So that is, we have to eliminate A and B 2 times. We have to differentiate the relation 2 times and eliminate A and B. So this is our equation number 1. So this is very simple board problem, dy dx. So A cos x minus b sin x. This is product x cos x plus sin x. So this is 2. Differentiating again. So d2y dx2 minus a sin x minus b cos x. This is product x into minus sin x into minus sin x plus cos x. X into x, derivative x unchanged, cos x, plus derivative of x is 1. Derivative of x is 1 and this is sin x. So x into minus sin x minus sin x plus cos x plus cos x. So look, if we take minus common, a sin x plus b cos x, you can take also x sin x within bracket because you know the help. This is y and this is 2 cos x. So d2y dx2 equals to minus this one from the relation. This is y with negative sign plus 2 cos x. So this is given. This is the required differential equation. What is the order? Order is 2 and degree is 1. Order 2, degree 1. Order 2, degree 1. 2 constant. So you can say order is 2. You have to find. So they are simple because relation is given directly. So problem number 20. So call it 1. So 2x, 2 constant, so 2by dy dx equals to 0. So ax plus by dy dx equals to 0. So we can perform derivative differential checking. Now look, if we divide it by a, so what we are getting? This is capital A. This is capital A. So b by a into y dy dx equals to 0. So we can differentiate it again with respect to x. So differentiating with respect to x. 1 plus b by a constant. So y into d2y dx2 plus dy dx whole square equals to x. This is y into double derivative dy dx whole square. Now we have to eliminate b by a from 2. So what is b by a? So b by a is, what is b by a? 1 unchanged. b by a is minus x by y dy dx into y into y dx2 plus dy dx whole square equals to 0. So finally, what we are getting, y dy dx minus x into y into d2y dx2 plus dy dx whole square equals to 0. So this is free form a and b. This is second order differential equation. Look, this is second order differential equation. Now, what is the order? Order is 2 and degree is also 1. So you can solve 18. This is also very simple problem. So you solve the rest of the problem from description box. So today we have discussed how to find order and degree of a differential equation and how to form differential equation by eliminating arbitrary constants. All are problems of JEE Main and West Bengal joint. They are very simple. So in the I will discuss differential equation in next class. So I will take then what are the different methods of solving differential equations. There are different methods. Then how to solve problems of JEE Main, typical problems, and so on. I will take 4 classes more. Thank you for today.